In this video, we'll discuss the most essential directives used in assembler programs written in MASM. Let's start with directives for defining variables. They enable the assignment of a name to a variable and the specification of its type. To define the variable of the size of 1 byte, we can use the db, byte or sbyte directives. The db directive has been available since the very beginning of MASM. Since version 6, two new directives appeared: byte, which is the same as db, and sbyte, which defines the signed byte variable. To define the variable of the size of 2 bytes, called word, we can use the dw, word or sword directives. The dw and word are the same and define an unsigned 16-bit variable. Sword defines the signed word variable. To define the variable of the size of 4 bytes, called a double word, we can use the dd, dword or sdword directives. The dd and dword are the same and define an unsigned 32-bit variable. Sdword defines the signed double word variable. Similarly, to define the variable of the size of 8 bytes, called a quad word, we can use the dq, qword or sqword directives. The dq and qword define an unsigned 64-bit variable. Sqword defines the signed quad word variable. There also exists the directive o-word to define 16 bytes variable called an octal word or double quad word. To define floating point variable, we can use real directives. The real4 defines a single precision 32-bit real number. The real8 defines a double precision 64-bit real number. And the real10 defines an extended precision 80-bit floating point variable. Variable definition directives can be used to define single variables, in the example shown var_x and var_y, data tables or strings. The list of operands determines the number of elements of a specified variable. It is allowed to use the question mark as an operand, signaling that the initialization value remains undefined. For allocating bigger data buffers or repetitive initialization values, we can use the dupe operator. The example also shows the resulting values of type, length and size operators used for variables defined. Type gives the number of bytes in a single element. Length gives the number of elements in a table. Size returns the number of bytes occupied by the whole table. It is equal to type multiplied by length. To define integer constants, we can use two directives, eq and the equal sign. While providing the value of a constant, we can write it in a decimal, binary, octal, or hexadecimal representation. For decimal values, we can use the suffix d or t, or leave the number without the suffix. Binary numbers we finish with b or y. Octal numbers we should finish with o or q, and hexadecimal with h. It's good to remember that a numeric constant defined with the eq directive can't be modified later in a program, while a constant created with the equal sign can be redefined many times in a program. Floating point numeric constants can be defined with the eq directive only. The number can be expressed in decimal or scientific notation. Text string constants can be defined with eq or text eq directives. The text can be taken inside apostrophes or quotation marks. Text constants assigned with both eq or text eq directives can be redefined later in the program. At the end, we show the template of the assembler program with constant definition, variable in the data section, and a single instruction in the code section. It also presents different types of statements.